Okay, so this is a question about the specific heat. The specific heat is essentially the characteristic constant for each material. How much heat do you need to change the temperature of the material by 1 degree C, certain temperature. So the equation, the specific heat is, we also call it a C, and this is coming from the heat capacity, the C coming from the heat capacity one. And also we can say water. Okay, so the heat capacity of the water, and we already know actually the heat capacity is 1 calorie, 1 grams of water by 1 degree C. So that's actually definition of calorie. Later the 1 calorie turns out to be a certain number of the joules, and that's the meaning of this. So another way to understand this is the meaning of the heat capacity is heat itself is essentially mass of water multiplied by heat capacity of water multiplied by delta T. Right? So how much temperature do you need? So if the temperature is going up, the Q value needs to be positive. Temperature is cooling down, the heat has to be taken out, so Q value has to be negative. So that's the one. The second one is understanding this wording of this problem here. So there is a water, which is that's the amount of the sample, and that was the initial temperature is 94 degrees C. And there is another water, which is at a different temperature, which is a colder water. And they are going to mix them together. So let's just give a little diagram here. So this is two scenarios. One is this is a temperature of 95 degrees C water, which is a 122 milliliter, which is a gram. Okay, the density for milliliter of the water is a 1 gram per milliliter, so just easier for dealing with a mass. Okay, and then the 255 grams of water, and this is going to be 25 degrees C. And then when you mix these two together, essentially in a beaker, what's going to happen is the heat will be taken out and then given to the colder water. So this is your final temperature, which is a degree C. They will reach the same temperature, and the delta T on the left hand side will be a cooling, and delta T on the right hand side will be a positive, which is a heating. So left hand side system will the Q value is a negative, and the right hand side the Q value will be positive. So let's establish the equation. Okay, so the Q value is essentially, because this is the one way to think about it is this is a whole system. There's no heat in and out lost by this, which just an internal transaction is happening. So the Q itself is actually 0. But it's just the Q left plus Q right. And as I mentioned before, this will be for them it is a negative value, this must be a positive value. At the end, you will get the same answer. So therefore, is now once you figure this one out, because this is an isolated system, I just only dealing with these two cases. All the heat from the left hand side will be used to raise up the temperature on the right hand side. That's what this question is about. So let's use this equation shown up here. The Q is a mass, and the C and the other values. Okay, so therefore the mass, what is my mass, is 122. What's my C value? Let's just say seawater. Can use actually calculate the one, but it actually does not need it here. And what's my change in the temperature? My final temperature TF minus 95. You don't need to actually change this into a Kelvin, because of the degree C and Kelvin in terms of the delta T is the same. So that's a 5 degrees C, and here once more TF in the unit of degree C, Celsius degree, and plus 255 seawater multiplied by, what's my final TF, minus 25. Okay, so just for a recap, this value will be a negative, this value will be a positive, so overall this will be a zero value. Okay, so that's how this one works out. And then what also know it is, if you divide this one by this value, this will be gone, and then I can calculate these values under here. Okay. Okay, so then this will be a 122 minus 255 TF will be minus 122 multiplied by 95 minus 255 multiplied by 25. Therefore, my TF, which is in the unit of degree C, is 46.9 degrees C. Okay, so that's my final value. So once again, I need to double check my answer, which is this value. If you plug that in, and that's the value in between those two, and this is on assuming that the one on the left hand side, the heat will be all used up to raise up the temperature of the system on the right, and then overall it is the combined left and the right is isolate system, so there's no heat in and out. All the heat on the left used to raise up the heat on the right. Okay, thank you for your attention.